Welcome to Coco's Nurses class. This morning I'm with Mr. Chuya and of course Edwin taking up the video. So when you like the video, kindly click like, or if you're not a subscriber, subscribe to the channel so that you support the channel. So this morning we'd like to see a procedure which we call MVA or manual vacuum aspiration. Now, for you to conduct that procedure, you need to be trained and, of course, know the instruments. And if, for example, you're doing gyne, you need to know what we really talk about when we say a patient is going for MVA or a patient will be taken for removal of a product of conception. Okay, that's maybe after an abortion. So, Mr. Chibia will go in details to explain what the indications for MVA, as well as how we use the instruments, meaning that how we're going to assemble the instruments, how are we going to dismantle the instruments. So, Mr. Chibia will tell us the details so that we understand how this is done. Mr. Chibia, kindly
Thank you
start
very
with
much,
the
sir. Thank you very much,
indications
sir.
for MVA.
Fine. Wonderful. So to start with, like my colleague mentioned, AMVA, these are simple initials. AMVA they stand for manual vacuum aspiration. You understand the way the manual is something to do with simply using your hands, not special technique, just using your hands. That's manual. Vacuum, we shall explain on this gadget. This is the one you're going to use to create some vacuum. Manual hands vacuum, you're going to create some vacuum here. Aspiration, you understand it. Aspiration is synonymous to sucking. To aspirate is like you are sucking. So manual, using the vacuum here to aspirate, to suck the products from the woman's uterus. So first thing first, I want to introduce the basic instruments that we use when carrying out the MVA procedure. You can see there's a speculum here. It's called a cascos speculum. Cascos speculum. We've got a sponge holding forceps here. Then we've got a valsalum here. To be detailed, a sponge holding forceps. At some point when we come to do the actual procedure on the patient, today I basically want to talk about explaining how this single instrument is used on the patient. So this one is a sponge holding forceps, indicating that it is used to hold sponge things like cotton wool or gauze soaked in, so that we use it for cleaning. Clean the valve as we prepare the working surface, okay, the working area. So this is the sponge holding forceps. This is called a cascos speculum. We shall use it to localize the cervix. We shall pass this instrument, insert it into the vagina, we gap it open until we're able to visualize the cervix. Because it's from the cervix where you're going to make sure that the os is visible, where you're going to introduce the cannulas. This is called a valsalum. At some point, we shall need to cramp the cervix so that we pull it nicely to maintain the tension so that the alignment of the uterus can be achieved. So much that when we reach the stage of introducing the cannulas or the dilators, we shall have no difficulties. So this valsalum we shall use to cramp the cervix so that we align the uterus and introduce the cannulas. These are basically cannulas. We call them cannulas, and they have different sizes. Sizes range from size 4 millimeters to 12 millimeters. May I make mention of one thing, that the numbers that are indicated on these cannulas actually denotes the size of the pregnancy in weeks, which can be actually sucked or managed by the cannula. For example, this cannula is size number 4, yellow, coded yellow. You can see they are coded differently, color code. The smallest 4 millimeters is yellow coded, the biggest is blue coded. Okay, there's number 4 there.
So
There's number 5 there.
The number of weeks in such a way.
Yes, number of weeks. The number which is indicated on the cannula denotes the gestation age in weeks, which pregnancy which this cannula can aspirate. I make mention the area I want to say. Number 4, size 4 millimeters can aspirate a 4 weeks pregnancy. 4 millimeters can aspirate the 4 weeks pregnancy. Number 5, 5 weeks pregnancy. You see? Number 6, just like that, up to 12 weeks. By the way, one important thing to note here is that MVA can be used, manual vacuum aspiration can be used to manage either aspiration of the pregnancy up to first trimester, 12 weeks only. 12 weeks, that is 3 months, not so? 12 weeks, 3 months. So a pregnancy of 3 months can be sucked out using number 12 cannula, 12 millimeters cannula. So the number here denotes the pregnancy in weeks, which this cannula can be used to manage that pregnancy, to aspirate the RPOCs or contents of the uterus at 12 weeks. That is number 12. And they are different color coded. Then the other thing we should note here is that all the cannulas from 4 to number 10, they have got what we call adapters. These color coded area, these are called adapters. They are called adapters because these are the sites who come and demonstrate how to attach them to the aspirator. We call them adapters. So the only cannula here which has got no adapter is size 12. Take note of that important point. All the cannulas from number 4 up to 10, they have got special adapters color coded. Except number 12, there is no 11 here. Except number 12, it has no adapter because the size of the area which you attach to the aspirator is almost the size of these other color coded adapters. So this one has got no adapter because the size is equivalent to the rest of the. Regardless of the size down there, the adapters, they are of the same size. We proceed. This is just to demonstrate how these cannulas are brought in before use. So this is a sterile one. It's packed. This is sealed. It has never been used on the patient. These ones we are using for demonstration purposes have been used before, and then they have been sterilized before. Probably they have been used on 10, 15, 20, 30 clients. Okay? So this is how they are brought before use on any patient. This is sealed. And this is how the aspirator. You can't do MVA minus any of these instruments we've mentioned here. This is called an aspirator. So this is equally sealed. It has never been used on the patient. So we are going to use it for demonstration purposes because I know it's going to give us good results. So let me open it. Let me open it so that we can start the demo. So this is the first, from the time it was manufactured, this is the first time it's being opened by us. New brand. Okay. So don't mind what I'm doing. I'll first dismantle it, then I'll demonstrate how to assemble it and disassemble it. So this collectively is called an aspirator, MV aspirating gadget. So let's dismantle. Let's see. We are going to start assembling it. Before we start assembling it, let's start explaining the different parts that make up the aspirator, MV aspirator. This one is called a valve. This one is called a valve. So this valve is the one which harbors what we call a valve liner. This is a valve. This one is called a valve liner, a rubber material. Okay, this is a rubber structure. This is plastic material. This is a rubber structure. Okay, and if you can see inside the valve, they have got some grooves. These grooves. This is where we are going to negotiate to insert this valve line. This is a valve. This is a valve liner. It lines inside the valve. Valve liner. It lines inside the valve. Can you see? It's very easy to just target this structure. You see? Target this structure, and this clip. Okay? So you simply target this. See? You see how it is fitting well? You see how it is fitting well? Then simply flip this one over. Simply flip this one over. And you are good to go. You see how it has managed to implant nicely? Okay? So we mentioned the inside part. This one is a valve. This one is a valve liner. Okay? Next, this is a stopper. Sorry, this is a cap. In Ibemba, we call it casote. This is a cap. This stays where? Stays here. Look at this structure. Look at this structure. Let these two structures correspond and fit it nicely. This is a cap. Next, this is a plunger. This is a cylinder. This is a plunger. Okay. This is a neck stopper, a collar neck, or a stopper. Simply put it, a stopper, because it has got its role to play as we are conducting this MVA procedure. So this plunger, it has got a O-ring, a plunger O-ring, because it's zero shaped or O shaped, so we call it a O-ring. It has got also a special technique which you are supposed to use for you to remove it, because at some point you have to remove this one so that you dismantle everything. As we put them in the decontamination container, all these things should be dismantled. You can't put all these things whilst they are mantled together into the sterilizing, then into the decontamination container. You will not achieve the intended purpose. Instead, you have to dismantle everything. Next stage, there's a technique we use to remove this O-ring. You press on the sides, then you push forward. This is new brand for your information. So the ring is tightly holding. So the technique is you push on the side, you like squeezing it forward until you see this area will be up, except it is slippery. There's some oil material, we call it a lubricator, which was first put at the time of manufacturing. So I'm gloved, and at least I can demonstrate to you how it is moved. You press on the sides, then you go forward like this. This area will be left up. Then don't use any sharp thing because it will distort the material. Then push forward and then hook it out. It's able to come out. Fine. So this is a plunger. This is a cylinder. A plunger and a cylinder. So make sure that don't turn, just go direct. This thing is lubricated. Just go directly. So you've connected the plunger and the cylinder. The purpose of the stopper is to prevent, in the absence of the stopper, to prevent, imagine we have separated products of conception from the uterine cavity, then suddenly you are trying to pull out. There is a chance that you can accidentally pull the plunger out of the cylinder completely and end up splashing yourself with the contents that you have aspirated from the uterine cavity. So the work of this stopper is to be like this. You set this one, bring this next stopper, it has some clips there, and then some holes there. Can you see some holes there? They are double. There's a hole there, here, there's another hole there. So we want these two clips to come and enter these holes. So the way we connect it is like this. You see? Then just maneuver a bit. The clips will go.
Repeat that one again.
Okay, fine.
Repeat.
When removing, go like this. This is out. Okay? So these, there are some holes there which we've shown. There's a hole there, there's a hole there, there's a clip here. Then we go like this. And you see? Then simply maneuver a bit. These will go into the holes. You see now it has fit? So inside there, don't know if the camera can pick up, you can see those two protruding structures, they are the ones preventing, yeah? You see? It's a stopper. It's stopping this plunger from coming out of the cylinder completely. And in the process, you prevent splashing yourself. With the RPOCs that we have aspirated from the uterine cavity, so we call it a stopper. Its work is to prevent the plunger from coming out completely. So it has been created for safety purposes. Okay. Next, this gadget has to be connected to the cylinder. Okay, bearing in mind that the alignment of these two buttons, these buttons should correspond to the wings of the plunger, right? And the wings of the cylinder, the collars of the cylinder, and the wings of the plunger. The alignment should be like this. Have you seen? Not each oh, this one is facing the other side. No, this one should be nicely. You can see it? And then the calibration of the cylinder, it has got some calibrations there. The volume of this cylinder is up to 60 mils. It can only accommodate 60 mils fluid or volume of RPOCs that we are going to aspirate. So when we shall reach a stage of conducting the actual procedure on the patient, we shall demonstrate. Once this thing is full, it should be disconnected. All the things from the cylinder emptied, then we charge, then start the procedure once again. So the point I'm trying to make here is that the amount of RPOCs or retained products of conception or whatever fluids they are aspirating from the uterine cavity is up to 60 mils. So this calibration is up to 60 mils. So having talked about the alignment, next we are going to do what we call charging. Charging is the process of manipulating this gadget to make sure that we create some vacuum inside there. MVA basically works on the principle of vacuum creation. If this thing cannot create some vacuum, cannot not attain some vacuum, be reminded that the procedure for MVA cannot succeed. Because how do you expect things to be aspirated when you cannot achieve the vacuum status? So make sure that before you start the MVA procedure on the patient, make sure that you test this gadget. If it is able to attain vacuum, then you are good to go. So this is how we create some vacuum. You press these two buttons at once, in and forward. You hear that sound? Press these two buttons, in and forward. You rock them like that. Okay? Next, what I'm doing, I'm trying to withdraw the plunger from the cylinder. Okay? Until the wings of the plunger, you can see the wings, those two, they are suspended on the neck of the cylinder. These two will come out like then they come and get suspended on the collar of the cylinder. What I've just done, this process is called the charging. What I've just done, I've just charged the gadget in readiness for use on the patient. In short, in there we have removed air. What has remained here is the vacuum. And is the same principle under which this gadget works. Man, as you creating this vacuum, achieving this vacuum, you cannot do any MVA. How do we confirm that we have created some vacuum there? There we go. We come back, we come and release these patterns like this. Can you hear that sound? There is a sound of air rushing back into the vacuum. Since we had removed the air, it remained the vacuum. The moment we release the buttons, this, having created some vacuum inside, it was trying now to aspirate the atmospheric air to come and occupy the area where the area on removed the air. The vacuum space has been reoccupied by the atmospheric air. Hence that sound, rushing sound of air getting into the cylinder to go and occupy where there was negative pressure. Let me once again demonstrate the charging. Push the patterns in, go forward. We've locked. Thereafter, hold it like this, pull until the wings of the plunger are suspended on the collars of the cylinder. How do you confirm that vacuum has been created? Go back and release the buttons like you can hear the sound of air rushing back into there. So that's how we create vacuum. Okay. Next stage. Once you test, now you can have everything ready to use on the patient. You prepare your patient, you prepare everything. Having confirmed that it's able to attain vacuum. At this point, if you test it, it's not able to create vacuum. Before even start the procedure, look for another gadget within which we are going to manage to create some vacuum. Okay. Next stage here, I'm going to demonstrate how we can connect these cannulas to this gadget. Okay. We mentioned to say these are adapters. These points are called adapters. The only cannula which has no adapter, color coded, is number 2 of the biggest. So even if we use the small one, right, remember these two flips should correspond to this, should correspond to this, should correspond to this. And make sure that these, there's a label there on top, it's called IPAS. We call them IPAS cannulas. These cannulas are called the IPAS cannulas. IPAS cannulas. So this label on top here, maybe we change the color, maybe the camera can pick. There's IPAS there, maybe IPAS is like this. Can you see? IPAS, even there's IPAS. We call them IPAS cannulas. Okay. So the size of the adapter are the same. The only difference is the sizes of the cannulas themselves. So this IPAS label should face you because this is the number which is facing you, the one conducting the procedure. And the dots should face you as well. Okay. So how do we connect? We connect Don't fugitive, like simply direct, like just push. It will go in. This wing should correspond to this wing, should correspond to this wing, so that the alignment is nicely. Even the calibration on the cylinder should be facing you, so much that when you are cleaning, you'll be seeing things moving into through the lumen, being conducted through the lumen of the cannula until you see them coming to occupy the cylinder. So this is how we connect. After you're done, like we shall demonstrate in due course how to do the actual procedure after you've connected like this, how to introduce this into the patient's uterine cavity, how to suck and the like. So when the moving is simple, you can simply do like that. When some contents are there, you take measure. Imagine that things were like this, right? You take note of how much you've actually aspirated it. You go and empty them in any container, which at the end of it, or it's either you master the number which is there, how much you've aspirated, or you don't mind, you just keep flashing them in some container. Then at the end of it, or you can measure them at once and take note of the amount of RPOs that you have aspirated. Remember, imagine that I've charged, right? I've charged, I've attached the cannula, and now I've introduced it into the inside of the uterine cavity. Okay? Once it is inside, for demonstration purposes, imagine this is the inside the uterine cavity, where these RPOs, retained products of conceptions, are. You introduce the cannula through the vagina, through the cervical os, until it goes into the uterine cavity. Imagine it has gone into the uterine cavity like that. These are retained products of conception. To confirm that this one has retained some vacuum and is able to work out nicely, now let's release the buttons. Have you seen what has happened? Hopefully the camera is able to take that. The vacuum space has actually sucked these RPOs from the uterine cavity, conducted through the cannula until they are visibly seen with the naked eyes, being collected in the cylinder. And you can take note of the amount, of course, like this. Because if like this, you get the long readings like this. Because 20 is from here, this is 30, this is about 58. This is about 58. So I'll repeat this stage again so that we probably I'll use the different cannula, slightly bigger. Okay? So I disconnect my cannula. Imagine this is the container where we are putting the aspirated RPOs from the uterine cavity. We keep them somewhere. Just simply do like this. Flash, 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 flash. Again, I'm charging. Forward. It's ready for use. Cannula, there we are. We connect it. Introduce it into the uterine cavity. There we are. Then we can release the buttons. Products of conception from the uterine cavities have been aspirated by the aspirator, and we're able to see them in the cylinder there. One thing to note is that the rate at which you are going to aspirate the RPOCs from the uterine cavity is dependent on one, the size of the RPOCs, the size of the retained products of conception that are remaining in the uterus, against the size of the cannula that you are using. Imagine you exposed this client to an ultrasound scan to help you determine the size of the RPOCs that are collected in the uterine cavity. They are telling you, measuring the RPOCs seen in the uterine cavity, measuring 3 by 4 centimeters by and then those measurements are slightly bigger compared to the type of the cannula that you have at hand. So the ultrasound scan will actually give you a guide to tell how much the size of RPOCs that it will detect. It is from that point that you as a provider of the procedure will actually be guided to determine which size of a cannula you use. So at what rate you are going to have the RPOCs aspirated from the uterine cavity is determined by the size of the cannula. If RPOCs are big, then you tend to use the small cannula. Every time you go in, you try to aspirate, it will be blocked because the size of the RPOCs are bigger than the lumen of the cannula. Meaning this cannula is too small, it cannot conduct the bigger structures, the bigger placental tissues, whatever remaining in the uterus. This cannula simply block out. Hence, they need to actually get the history properly from the patient. That what the you determining the gestation age you actually guide you. We mentioned earlier on to say the size of the cannula. The size of the cannula, as indicated with the numbers 4, we mentioned to say size 4 can aspirate the pregnancy gestation age 4 weeks. 4, the number age